All right, guys, we are just about rounding up. Hey everybody, we are just about to round up all of the graphing polynomial function videos. This is our last one, 834, and we're going to be looking here at gathering all of the information we can about the polynomial function. So everything that we've ever talked about with all the other functions, we're going to talk about with this function. So that's our domain and range and our x-intercepts, our y-intercepts. We're going to be talking about increasing and decreasing and maximums, minimums, all of that stuff is going to come up here. And you guys have been so good at finding all the information on the graphs that I have no doubt that this is going to be a success for us. So make sure you've got your graphing calculators because they've been a really big help at finding things like the maximums and minimums and some of those zeros. So have your calculator with you and let's get started. All right, so we've only got two examples, and I just wanted to get as much information as we could about each of these. So go ahead and start by putting this into your graphing calculator, and you may enter it just as you see it, as in with the parentheses. So take a moment and do that now. All right, now what you should have here, and you can look at the graph of it and decide, and if you have changed your graph recently, maybe Zoom 6 will bring you back to seeing the normal picture of this. But what I notice is the normal picture isn't really good enough. Like I'm not really seeing what's going on, that it goes really high and goes really low. So I'm going to probably want to change my window so that I can see my maximum minimums. And I have no idea what I'm going to change my windows to, but it looks like my x's are just fine. It's my y values that have an issue. So I'm going to change my y minimum and my y maximum to something a little bit more extreme. I'm going to try 50s, negative 50 and then positive 50, and just see if that helps. So I'm watching it graph on my calculator, and 50 seemed to be good. Maybe I could have gone a little bit less than that, maybe 40, but I can see the picture of this graph. So the function goes like this. This is just a rough sketch of it. It looks like that. Kind of looks symmetric, actually. Now, the next thing is I want to be answering the question, what are the factors? And the reason I ask for the factors is because they help me find the zeros. So the factors help me find the x-intercept. So I always want to find the factors first. It makes it a lot easier. So the factors that I have here are x. They are x minus 2 and x plus 2. And then x squared plus 9, which we should know we cannot factor anymore into real numbers. Now the next thing I need to find are what are my zeros, and I need to find the real and non-real zeros. So factors really help with this because I'm using the zero product property at this point, and I'm going to write them as ordered pairs, so 0, 0, and then I have 0, oops, that should be 2, 0, and then negative 2, 0. And then I have these non-real zeros that are going to come out of the last one. So I'm going to write those as, I'm not writing them as ordered pairs, but I'm going to write x equals plus or minus 3i. So those are the non-real zeros, which graphing them as ordered, or writing them as ordered pairs is not appropriate mathematically. Okay, my y-intercept. Remember, your y-intercept comes from plugging in zeros. So you need to remind yourself that, write down plug in 0. But what I notice what happens when I plug in 0 is that I get 0 because this would be 0 times negative 4 times positive 9. But it's multiplication, so my y-intercept is 0, 0. The next thing I've got are my relative min and max. So I'm just looking for my maximum minimums, and I'm using my graphing calculator to do that. So I'm going to let you pause the video now and using the second calc feature to go back and find the maximum and minimum values that you see. So pause now. All right, so it looks like my instincts of this being pretty symmetric were pretty much right on, because if you look, I have a positive x with a negative y, and then it's the reverse. It's the negative x with the positive y. So this is indeed a very symmetric graph right over that origin. So we can see that. Now I want to talk about my domain and range. My domain and range are what x and y values get used. And in this function, seeing as though my end behavior takes me all the way to positive infinity in one direction and negative infinity in the other, I'm going to have all real numbers for both my domain and range, which you may write as negative infinity to positive infinity, or the all real number symbol that we use. I'd like you to add on here increasing and decreasing. So we're going to talk about the intervals of increase and the intervals of decrease. So I'm going to use a highlighter to demonstrate this. So if you've got one and you want to grab it, that's great. So I'm going to first highlight the areas that are increasing. And I can see that they're increasing over here, and then they're increasing again. Now we use the x values on our x-axis to describe where that's all happening. So it's happening once you reach the x values of my max and min. Not the y values, but the x values. So I would say that this is increasing from negative infinity all the way up to negative 1.2546. And then it starts increasing when it gets to positive 1.2546 and continues on to infinity. And it's only between those two values that it is decreasing. So it's decreasing at negative 1.2546 all the way to positive 1.2456. Remember, I'm using x values to describe when the y's are rising or falling. So we've now covered our factors, the zeros, the y-intercept, looking at the max and min, the domain and range, increasing and decreasing. The only thing left would be end behavior, so let's throw it on there as well. So as x goes towards positive infinity, what is the y doing? Well, it's going up. Okay, so as x is going off to the right, the y values are going up. And as x is going off to the left, to negative infinity, the y values are dropping. They're going down to negative infinity as well. Not really sure what's going on with my pen. Let me change it again. Let's see. All right, we got one more example. Let's give it a try. So take a moment again, and I want you to pause so you can put this into the graphing calculator and reset your screen to Zoom 6 and maybe adjust the window if you need to. And when you've got that, go ahead and unpause. Okay, so if you're back, I noticed that I didn't need it to go my window to be at negative 50 to positive 50 for the y values, and that I chose just 30. So I did negative 30 to positive 30 for the y min and max. I didn't really need as many as 50. It kind of gave me a good picture around 30. I first tried 20, but that just seemed, I still missed the max and min. So I look at this shape, and my first step here would be to factor, but I have to kind of think about how am I going to get my factors. And in this case, I might try to say, well, I think I see one at positive 3. I think I see an intercept at positive 3. So I'm going to use synthetic division starting with positive 3 and just see where it takes me. 1, 3, negative 13, negative 15. And if I'm right, and this does turn out to be the right place, which it does look like it, so 3 was one of my zeros. So I already know one of my zeros, which means I actually know one of my factors to be x minus 3, right? Because they go together. That now I can take that leftover x squared plus 6x plus 5 and with no doubt be able to factor this and be certain that I not only know my other factors, but I also know my other zeros. So that would be negative 1, 0 and negative 5, comma 0. So you could have started with the negative 5 or the negative 1 in synthetic division and then just had something different to factor, but it would have resulted the same way. It's kind of like taking the number, let's say 28 and saying, well, I know it's divisible by 2 and I get 14, but someone else goes, no, I'll divide 28 by 7 and I'll get 4. And so either way, this now turns into 7 times 2 and this turns into 2 times 2. It's the same thing. It's 2 times 7 times 2 or 7 times 2 times 2. So if you think about it, it doesn't matter where you start. If you're factoring it, you'll get down to the same thing in its base prime factorization is what it's called. Okay, so the next step would be to find our y-intercept, because we have all of our factors and we have all of our x-intercepts. My y-intercept, again, comes from substituting in 0. And if you put in 0, not into the factored one, but how about the original, you end up very easily canceling all the x's and getting 0, negative 15. There's my y-intercept. To find the maximum minimum, go ahead and pause the video and use the second calc option and find the max and min, and then join me when you're ready. Okay, so you can see that this one also has a little bit of symmetry, if you will. If you think about at least maybe not that it's equivalent in the x values, but your y values are pretty, they're opposites of each other. So that's also something that's pretty unique about this particular function. Okay, so let's grab our domain and range, and since we do see that it is going up, down, up, that it's going to cover all of our x's for all real numbers and all of our y values as all real numbers because it's stretching everywhere. And then let's grab our increase and decrease interval. Here we're going to remember use the x values. So if this takes me here and that's using my maximum of negative 3.3094, that I would increase from negative infinity up to that value. And then we would start increasing when it gets to the next x value, which is 1.3094 to positive infinity. And the decrease happens in between there again. So there's our decreasing values from negative 3.3094 to positive 1.3094. And then lastly, I guess we can add on our, as x is heading off to the right, the y values are going up. And as x is heading to the left, which is negative infinity, the y values are going down. So there is everything that we would be interested in knowing about the graph of this polynomial function. So please take any notes that you need to, or highlight any areas that you want to address when we're back together, and we'll be sure to answer all your questions. So great job.